guys. So today in this video I'm going to explain how to solve problem number 498 diagonal traverse, which is of category medium. So in this problem we are given a matrix and we have to traverse the matrix diagonally. So let's see how we are going to approach this problem. Okay, so here I have already written one example. So this is our input, the given matrix, and this is how our output should look like. If we see the matrix, we have to traverse it diagonally, and when we are traversing it diagonally, either we are going in upward direction or either we are traversing it in a downward direction. So we have m cross n matrix. So let's consider let's consider the direction and try to traverse the matrix. So here I write the direction. It's up. If it's up, then I'll initialize it to true, and if the direction is down, it means it's false. So let's check the ideal condition. If I am at 7 and I have to traverse upward, so what I'll be doing is I'll be decrementing my row and incrementing my column to get 5 from 7. Suppose R is my row and C is my column. So what I'll do, in the ideal condition, I'll decrement my row and increment my column. Okay, so this is my one condition. Now if I'm at 1, if my row is 0 and I have to change the direction and go to another cell, that is 2. So how I'll do it? So I'll increment the column and change my direction to false, that is downward. So this is my one condition. Other condition would be if I am at the last cell, that is at the last column and at row 0. In that case, if C is equals to n minus 1, in that case what I have to do is increment the column and make the direction as false. Okay, so these are some conditions that we have to consider while traversing in upward direction. Now let's check for the downfall. If I'm at 3 and I have to traverse, like suppose I'm at 6 and I have to go at 8, so how I'll do it? It should be just opposite to this one. So I'll increment the row and decrement my column. Okay, and what would be my first check? If I am at the last row, if my row is equals to m minus 1, then what I have to do? I have to go to 8. Like assuming if I'm at 4, here we don't encounter such situation, but if it is a 4 into 4 matrix, in that situation, if we are at the last row, suppose 8, if we are at the last row and then we have to go to 9, how we are going to do it? We have to increment the column and set the direction as true. Other condition would be if I'm always at C is equals to 0 at the first column, then we have to go to next row, so increment the row and change the direction to true. So these are few conditions that we have to consider while going downwards, and these are the conditions we have to consider while going upwards. So now let's talk about the time complexity and space complexity. It's super easy because we are traversing each and every cell of the matrix. That's why the time complexity would be m cross n, big O of m cross n. And for space, we are not using any extra data structure or extra memory, so it's just big O of 1. So yeah, this is how we are going to approach the diagonal traverse problem. Okay, now let's try to code it out. So I'll have row, I'll have column initialized to 0, then m would be length of the matrix, n would be the length of the matrix 0th element. So now I'll define result m into n. I'll have idx initialized to 0. Okay, now the while loop, my idx is less than m cross n. First I'll store the result, idx is equals to mat r c. Then I'll increment the idx. Okay, I forgot to initialize the direction. Initially it will be true, so if my direction is true, then we will be writing all the cases for the upward direction. So if my r, or let's check this, if my n, if my column is equals to n minus 1, n minus 1, and then I'll be incrementing the row and direction will be set to false. Else if my row is equals to 0, my row is equals to 0, then I'll increment the column and direction would be false. Else just decrement the row and increment the column. Oops. 1, 1. Okay, now the else part. If I'm going downwards, so for downwards my conditions would be, let's first write the normal condition. If I'm going in a downward direction, then every time I'm decrement my column and increment the row. Okay, and here if my column is equals to 0, Then in that case, I have to increment the row, and direction I have to set to true. And here, if my row becomes so m minus 1, a minus 1, if I'm at the last row, then I have to increment the column and direction to true. So all of this is done. Then again I'll come here at the result, I'll add it, I'll increment the index. Okay, now let's return the result. Let's try to run it. Correct. So all the cases are, like, two cases are passed. Let's try to submit it. Perfect. So it beats by 81%. So that's how we solve the diagonal traverse problem. There is one more problem which I'm going to cover in the another video, in the next video, that is the spiral traverse. So it is similar, but we have to traverse the matrix in the spiral way. So see you guys in the next video. And also, if you guys have any questions, any queries, any doubts, just comment, just mention it in the comment section. I'll try to clear them. Thank you.